Dear Tim and Moby, we're learning about levers in science and I'm totally confused. Can you explain them? From Carlo. I think Moby just got a taste of levers in action. Levers are pretty simple, really. They allow us to move things more easily by magnifying our efforts. A lever has 4 components. The lever itself is a length of relatively stiff material. The fulcrum is the point on which the lever balances or pivots. The load is the weight or resistance that needs to be overcome. And the effort is the force you apply to the lever. These elements can be rearranged to make 3 kinds of levers. This is a Class 1 or first-class lever. The fulcrum is positioned between the effort and the load. A seesaw is a good example of a Class 1 lever, so is an old-fashioned scale. The thing to remember with levers is that distance and effort are interrelated. If you're willing to increase the distance over which you exert force, then you can decrease that force and still get the job done. It's like the difference between lifting a safe straight up over your head and pushing it up a hill to the same height. The total amount of effort expended is the same in both cases, but pushing it up the hill lets you extend the effort over a longer distance so you don't have to push as hard. Take a look at this simple Class 1 lever. See how the fulcrum is in the middle? Lifting Moby in this case requires a lot of force. You don't have bones. Anyway, this is the distance over which we have to exert force to lift Moby to the top. We can increase this distance by moving the fulcrum towards him. Since the distance is increased, the amount of force needed to lift him is decreased. Let's see some more levers. The fulcrum in a Class 2 lever can be found at one end with the effort applied at the other end. The load is somewhere in between. A wheelbarrow is a Class 2 lever. Since the load is close to the fulcrum, the effort needed to lift the load is spread out and lifting is easier. In both Class 1 and Class 2 levers, the effort needed to move the load is smaller than the load, but the effort travels further. Class 3 levers have a fulcrum at one end like a Class 2 lever, but in a Class 3 lever, the position of the effort and load are reversed. Here, the effort needed to move the load is actually greater than the load itself, but the load moves further than the effort. Tweezers are Class 3 levers. So is your arm. Before Moby and I understood levers, playing on a seesaw was about as much fun as waiting for a bus. But if Moby, who weighs about twice as much as me, moves halfway up the seesaw, we can balance with no problem. Ah!